All right. Good morning, everyone. Welcome to Comp 3350 Software Engineering. Thank you all for helping me get this set up. I used to just do all of these myself, but then I realized it would be 16 times faster if I just come and ask you to do it. So it was 16 times faster because this used to take me like an hour to get all this set up. So great. Thank you all for helping me with that. Today, we are going to be spending the entire class talking about design patterns. This is our big goal for today, is to talk about design patterns. We're gonna really quickly just define what design patterns are. That's the very first thing we're gonna do, and then we're gonna take a whirlwind tour through a variety of different design patterns, which you have seen at least one of as you're putting up these different posters for me. In front of you, what I've placed is a printed out booklet of all the code I'm going to show you, just in case you don't have a device in front of you with a screen, so you can have a copy of all of the design patterns that we're looking at. And then what you've put up on the wall is a single design pattern. And the exercise that we're going to be going through here is I'm going to ask your team eventually to circulate through these design patterns. So actually stand up and walk around the room, look at the design pattern, and start to decide whether or not you would be able to use this in the project that you have right now, or if you think you might be able to use this design pattern going forward. So when we get to that, I'll explain again what I'm asking you to do, but let's get started with design patterns for now. So we have been talking about software design principles. We've been talking about software design principles. We've been talking a little bit about patterns in the form of architectural patterns specifically. Architectural patterns in this course, well, that's it. You're going to use 3-tier and you're going to like it. And that's the end of the conversation that we have about architectural design patterns. When you take Comp 4350, so Software Engineering 2, that's where you start to get to make decisions about the architectural pattern that you're using. That's a course where you start to do like a web server with a device, and you have interaction between those things. And then you can start to think about buzzwords like microservices. Maybe you've heard that word before to describe something. That's a different kind of architectural design pattern. In this course, architectural patterns are, you're going to use 3-tier and you're going to like it. End of conversation. Architectural design patterns, they're really, really big picture design patterns. This is basically how you build your entire application. This is not thinking about classes. This is not thinking about smaller parts of your application. This is thinking about the whole thing, all of the different classes and how they're going to interact with each other and how things are going to be structured. The solid principles, so single responsibility, open closed, list-gov substitution, interface segregation, and dependency inversion, these solid principles aren't patterns. They're principles. They're not patterns at all. They're principles. They're more like guidelines for how you should go about designing software and things that your software should do to be a well-designed piece of software. But they're also really small picture. So architecture is big. It's the whole thing. Solid principles are small. They're really limited to just classes, individual classes. And sometimes they go as big as how different classes are related to each other. So like open closed is talking about using extension and inheritance as opposed to having switches or if-else blocks and using instance of. But these principles are very, very much tied to classes and inheritance. They're not really any bigger picture than that. So we kind of have this gap in between the really, really big picture and the really, really small picture for things that we can be looking at in terms of how to build software. Design patterns are common solutions to problems that you see when you're building software. Here's a small aside. This is from a Sears catalog. This is from a Sears catalog. Way back when, you used to be able to mail order houses from Sears. And like what I like to think is, imagine, this is hard to see, but imagine being able to buy a house for $2,000. Also imagine then building a house. I don't know, like it's a common solution to problems that we see commonly in software development. This is not copy-paste code. I'm showing you a bunch of code today. Don't get me wrong. I'm going to show you a bunch of code. But the code that I'm going to show you these are implementations of a design pattern. So I'm going to describe what design patterns are, like what each of them are. I'm going to show you an example of what that design pattern looks like. But this isn't something that you can just copy and paste into your own code. The structure of the pattern is something that you can apply to the code that you have, but you can't just copy and paste my code and then use that. A good analogy for this is that they're blueprints for a solution. This is a general idea, a structure of how you could fit several interrelated classes together to solve the problem that you're looking at right now. But it's not going to be a piece of code that you can just grab and copy and paste and dump into your project wholesale. There are 3 major classifications of patterns. This is just ways that we can group design patterns together. There are creational patterns. These are design patterns that are used and related to creating instances of classes. There are structural patterns. These are patterns that are related to the structure of your code, so how classes are interrelated with each other and how they work with each other, or how they're related to each other in terms of a hierarchical pattern. And then there's behavioral patterns. So how a bunch of different pieces of code will work in terms of a specific behavior that you're trying to model. So this is not that inheritance behavioral model, but more of a bigger picture. We want a bunch of different classes to do some bigger picture behavior. These are the examples of the patterns that we're going to look through today, and I'm going to move fairly fast through this. I don't want to dwell too much on this. These are all in our course outline as readings, so all of these are, you can find more detailed articles about these. I just want to make sure that we're all on the same page today. We all know minimally about each of these design patterns. If you've read all these, excellent, great. If you haven't, I'll get you up to speed sort of quickly, but you're going to get a better idea of what this looks like through the articles that I posted on there. They're very well written. They are very, very well written, so it's worth taking a look at those if you're kind of uncertain about any of these. First are some creational patterns. There's dependency injection. This is something that you have seen before, but we'll take a look at it in isolation. There's the builder pattern. This is something that I commented a couple of times on some projects to suggest maybe you should think about using this pattern. Now we're talking about it, so now you should hopefully be able to apply that. There's the singleton pattern, which you have seen before. For structural, there's a pattern that's called adapter. This can be useful for some of the stuff that you're doing in your projects. There's facade, there's special case. And behavioral, finally, there's chain of responsibility and observer. This is just a small subset of design patterns. We don't have time. There's just textbooks on design patterns. We don't have time to talk about all of the design patterns that there are, but this is a good selection of things that could apply to the projects that you're working on right now to kind of give you a sense of what they look like. All right, so dependency injection. This is something that you have seen before. This is something that you've seen before in the sample project. And the basic description of dependency injection is that you add a constructor to a class that takes the interface of the dependency that you have. So the literal interface type as opposed to an actual implementation of the class. This is quite literally, this is that D in solid. So depend on abstractions and not constructions or concretions is the word that they use, implementations. Don't depend on implementation details, but instead depend on abstractions. Here's a little code sample that's isolated all by itself. This is the piece of paper that you have in front of you. This is on the course webpage. There's lots of places where this is. The idea here is that I have a class that I want to inject a dependency into. I have an interface that describes what the dependency can do, and then I have an implementation of that dependency. In the constructor for this class, I've added a new constructor, so I don't have that just the null constructor. Now I have another one that accepts an argument, and the argument here is the interface of the dependency. I use the dependency using just its interface. I don't know anything about the implementation details. That's it. And then when I construct an instance of this class that I want to inject a dependency into, I do actually have to create an instance of this dependency. Yeah, I still have to actually do that, but I just pass that dependency into the constructor here. So dependency injection is basically when I create an instance of a class, if it has dependencies, I give it those implementations. It doesn't create them itself. I give them to it. A singleton, another creational pattern. This is something you've seen before in the sample project. The basic idea here is that you can only ever create one instance of a class. The restriction on this is going to be done using features of your programming language. So you're going to hide your constructor. You're going to use a static instance or a static class variable to have exactly one instance of something. Here's an example of that before I say why this is useful. Here I've got a single class instance called singleton. I've marked its constructor private. The null constructor is private so that nobody can call the constructor. If I try to call that constructor from somewhere else, it's a compile time exception. This is not visible. I can't call this constructor. On the class itself, I have a static variable that's an instance of this type, and I have a static method that gets me that specific instance. The only way that you can get an instance of this type is by calling this getInstance method instead of calling the constructor for this. This pattern is useful for things that are expensive to create. One of the places that this is used in the sample project is to create instances of the persistence layer classes. The persistence layer classes have things that are expensive to create themselves, connections, although they just create the connections themselves, but shared resources. We want to have the same persistence layer for everything, especially when you were working with a stub database. You want the exact same instance of that class for all instances of the logic layer that you've got. Patterns that are related to this, I'm not sure if Rob has been talking about thread pools in OS. Has he? Yes? No? Not really? I don't know. This is kind of related to these idea of resource pools. So a thread pool, threads are actually kind of expensive to make in operating systems. If Rob told you that they're cheap, he's lying, but I'm pretty sure he didn't. Threads are kind of expensive to make, so a common pattern is to just make a bunch of them and then keep them around forever and just give them work when they need to do work, as opposed to making new threads with pthreads. Similarly, connection pools. This is really common with databases, especially when you've got database connections that are going to a separate server. Creating a new connection to a server is an expensive operation. So having existing connections just laying around that you can pick up and grab, having a static instance of this is helpful. So a single instance of this is helpful. The builder pattern is when you've got a class that has many, many arguments to the constructor. So one of the things that we looked at previously in this course was that person address class that looked terrible but didn't violate any solid principles. Having classes like this that have many, 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 many arguments to the constructor is really painful to create instances of that, because you have to keep track of all of the arguments that you're passing to the constructor. So a strategy here is to add a different class that's responsible for building that. So here's an example of builder. Here's person address. In the sample that you have in front of you, I've cut some of these properties just so that it fits onto one page, because this is a terrible class. It's a terrible, terrible class. But you still have your same instance class. I've added a private null constructor here so that you can't call the constructor, the null constructor, from outside of this class. I still have this existing constructor. I've left that in there. You can still call this really big constructor if you want to. There's no reason for me to stop you from doing that. But I've added in another class here. So this public static class person address builder. This is an inner class. I don't know if you've ever seen this in Java, but this is an inner class within the class itself. It's static because we don't want it to be bound to an instance of the enclosing class. We don't want to create an instance of the enclosing class to do that. But because it's an inner class, it has access to all of the private things that are inside that class. So here, our address builder, we can have a constructor for that. We can call the constructor for person address that's been marked private. And another pattern that's added to this builder pattern is that we have chaining, method chaining. So every one of these methods that we're calling, first name, last name, care of, we're returning person address builder, and we're just returning this. Let me show you what this looks like in practice. So actually using this thing. In a main method, we would do something like create an instance of the builder itself, and then on the builder call method. So call first name, dot, call last name, dot, and we're just keep using that same instance because it's returning this on each of those. The final thing that we do is say dot build, and that gives us an instance of the class that this is trying to construct. Okay, this is kind of a weird thing with the return this. This is maybe something you've never seen before, but it's just making it a little bit easier to do method chaining, so we can just repeatedly call methods on the same object without having to say like builder dot, builder dot, builder dot, builder dot, builder dot. Good, good, okay, good. So those are our creational patterns. Adapter is a structural pattern. An adapter is a class that transforms outputs from one source to your own internal data model, or one class type to your own internal data model. This is usually used in places where you don't have control over how this other thing is being created. You don't have control over it. So let's take a look at an adapter here. An adapter here is going to consist of some incompatible class or some source of data that you do not have control over. So this class here would be something that you didn't write. This is coming from some framework that you're using, so some Android thing. This is coming from some web server that you don't have control over that's generating JSON or XML or something that gives data in a way that's not compatible with your existing data model. In the case of a class, this means that you've got some incompatible interface. So this doesn't really fit in with the interface that you've been working with for your own internal data model. You do have an interface that is kind of just stating what the compatible interface is. So what the thing is that your classes can do. These are the ways that you are interacting with your classes. This is your own class here, compatible implementation. All this is this is my data model. This is how I work with my data model. This is how my logic layer and persistence layer and interface layer are all expecting my data model to look when I'm working with it. The adapter approach here is that you take this interface and you create a new class that implements that interface, and you compose this object. So this is delegation and aggregation, composition. We're composing this object out of an instance of that incompatible thing, and we're really just passing method calls to the appropriate method for that other object. So we can use this to transform data sources from some external data source, or we can use this to transform APIs from some other API that we don't have control over. The word adapter appears liberally in Android's classes. Yes. The persistence layer in the sample project is an adapter. It's all adapters. It's all adapters to SQL. It's all adapters to a relational database. The stubs were actual literal implementations that you wrote with your own data model. But now you're moving to this other thing, this external thing that has another kind of interface, and you're adapting that external interface to fit with your own internal data model. A facade is related to an adapter. It's related to an adapter, but the idea here is that instead of just wrapping one single class, it's wrapping and coordinating possibly many different classes or wrapping many different methods. So here's my facade. I have this class that's maybe provided by my database vendor. I have to call these methods in a specific order. I have to connect and then run a query and then disconnect. A facade that sits in front of this is a class that just has a single method. I call that single method, and that single method is responsible for doing all of that work. So it's simplifying the interface for me so I don't have to think about doing all that stuff. This is different from an adapter in the sense that you're kind of coordinating different things that are happening, coordinating behaviors, as opposed to transforming one thing into another thing. The special case pattern is another structural pattern that basically says, rather than having nulls and getting null pointer exceptions when you have nothing coming back or something that should represent nothing coming back from an interface, you just have another class that still satisfies the interface, but it means nothing. So here's an example of special case here. I've got these classes, me, you, and nobody, and there's an interface type person. I've got this class here that's a person finder. It looks for something, and if it does get nothing back from whatever database it is that I'm using, I would instead return an instance of this nobody class. The thing that I'm accomplishing here is that the code that calls this find person no longer has to worry about null ever being returned. It can always just use the instance of whatever's returned. It doesn't have to check for null itself. One thing that this does accomplish is that you don't have to have if thing equals null around every time you call this method, because it's being done within the method itself. So you're kind of reducing code duplication there. The chain of responsibility is a sequence of classes that take data. This is usually a domain model object that you've got, transform it or use it in some way, and then pass that along to another instance of a class. So let's take a look at a chain of responsibility here. This is a little bit longer. I've got this class here called chain. I've got a method on it called runChain. I've got an interface here called chainable, and then I have several operations that can be applied to this. So one thing that I have used this for in my past is working with biological sequence data. The data comes off of the machine in a compressed format, but all the tools that I was using to analyze it couldn't read compressed data. They couldn't read compressed data. So I had to go through the process of decompressing it and then running these tools on it one at a time, and then my job was done. But I can represent this as a chain and a sequence of actions. So what this does is it's basically a linked list. It's a linked list of operations that will happen on something. So you can have this decompress class that will take the next thing that it should do, and then it satisfies this apply operation interface. So decompress it and then do the next thing that's in the chain. I don't know what it is, but I'm just going to do whatever the next thing is in the chain. Analyze it is going to analyze the contents of the file, do something with it, insert things into the database, and then apply the next operation. And then we have a special case, which is end of chain, which just does nothing. It doesn't do anything. It's the end of the chain, so it just stops. So I don't have to do checking for null in this. Chain of responsibility is a linked list. Hey, it's a linked list. Oh, good, yes. I guarantee you're doing linked lists in operating systems too. Yeah. Not yet? Not yet. OK, you will be doing linked lists in operating systems. I guarantee it. This is like the school of linked lists. Yeah. The last thing that I'm going to talk about here is the observer pattern. And the observer pattern is basically pub sub. So you've got a publisher and you've got a bunch of subscribers. And you can think about that in the literal like newspaper and subscriber to newspaper operation. You've got classes that are interested in events happening, and then you have a class that generates events. So it wants to notify these classes of other things happening. This is an alternative to you just sitting around and polling, asking, is this thing done yet? Is this thing done yet? Is this thing done yet? Rather than doing that, you're inverting that relationship. And you're saying, hey, let me know when you're finished. I'm going to go do other stuff now. The observer here, the example that I wrote for this, actually uses the chain of responsibility. And it's a little bit longer because it's using several different patterns, all in one example. The chain manager here has a singleton that is the chain manager. It has an interface that allows things to subscribe to events. And the way that it subscribes to events is that it gets added to the list, to a linked as an array list. At least it's not a linked list in this case, but let's just do it. It's a linked list. All right, cool. So add itself to a linked list, and then this is literally just a loop. When that event happens, when I want to notify listeners that an event has happened, I just go through a loop and tell all of them. I call a method on all of them. The listeners themselves are going to be an interface that has a single method on it. This is the method you should call when you are notifying me that this job has finished or that this thing has happened. And then commonly, you have some kind of a UI, a presentation layer class that's updating its display as things are happening. So progress display here implements listener, and it's got an update method that really just says this thing is finished. The start method here launches this chain of actions. It subscribes itself, so it's passing this to that class. So again, this kind of strange use of this that you may not have seen before, but it's basically saying, I would like to subscribe myself to this chain of events. And then these methods, I've taken the rest of them out, but the decompress one, we modify that now to get an instance of that chain manager, that singleton, and then notify that this is done. So notify the listeners that I have finished whatever it is I'm doing before I move on to the next chain of operations. All right, that was our whirlwind tour of patterns. Yeah, this is signals and threads. This is usually applied to multi-threaded applications or GUI applications as opposed to single-threaded applications. That's our whirlwind tour of design patterns. The job that I have for you now is that I want you all to, don't get up quite yet, but you will get up. I want you to get up out of your seats, and I want you to start visiting these design patterns that you have put up on the wall. You can start at the one that you put up yourself. So start at that one, and then I'm going to have us moving clockwise. So if the clock is on the floor, oh man, the clock is going that way. So yeah, go clockwise. So go around the room this way, please. So that would be like, if you're looking at the wall here, it's go to the right. Everybody go to the right. I want you to visit each exhibit. I want you to discuss. First, have you ever seen this before? Have you ever seen this design pattern before outside of this class? So yeah, you saw all of them like 5 minutes ago. Have you ever seen this outside of this class? If you have seen it, but not used it, when and where did you see it? If you have seen it and you've used it, when and where did you see it? I want you to answer these questions with your team on the sticky notes, and I want you to leave them behind as you're visiting each of these things. Ideally, what I'm looking for you to write down is your team number on the sticky note. Stick it in, no, I've never seen this before, or yes, I have seen this before, and where have I seen it? So write something down extra on the sticky note. The more important part of this is the part where you should be spending the bulk of your conversation. Can you use this design pattern? Some of you will hopefully, because I've told you that you should be using it, some of you will be able to say, yes, I can use this design pattern. Some of you will be able to say, I'm already using this design pattern in the code that I've written for this project. If you can't use it, so you cannot think of any way that you can use this in your existing code base, or you can't think of any way that you can use it going forward as you add new features, put your sticky note in the no area. If you think you can, because you can see right now, this is an ideal solution to a problem that we have, stick it in the yes, and write down like which class names you think would fit into that. I'm going to have my timer running. I'm going to be giving you about 5 or so minutes per station here. I'm going to give you 5 or so minutes per station. There's 8 design patterns, so that's 40 total minutes, which is pretty much bringing us to the end of class today. So I have more supplies at the front if you need them. Because it's going to be a little bit chaotic at the end of class, I'm going to ask you what I want you to do right now before we get started. At the end of class, please bring these papers and bring everything up to me, please. Please bring all of the papers that you have. If you don't want the handouts that I've left for you, just bring them up to me, because it's faster for me to recycle them on the way out. Or alternatively, you can just recycle them, but please don't leave them on the tables, because there's another class in here after this, and it's, I don't know, a little bit annoying for me to have to pick them up at the end. Nah. Okay, so we all know what to do? We're good? Okay, please go ahead. All right. So I think that what I'm going to say is what I would like you to do now is we've got just a couple minutes left in class. I'm hoping that you've seen several of these different kinds of patterns and are able to start thinking about how you can or can't use them in your projects. I want to make sure that we can leave this space tidy for the next class, so I want to have enough time to do that, and I don't want to steal time from you to do that. So what I'm going to ask you to do politely now is look at what my life looks like right now, and please just bring all the stuff up to the front. So grab whatever poster is closest to you, bring it up. Markers, sticky notes, all of that stuff. And then I will otherwise see you all next week. Bye, everybody. Yes, please. Thank you.